Is how I got an A star in GCSE and A-level physics. Full disclosure though, when I did A-level, there wasn't an A star available, so it only went up to A. So I'll put that out there right now. But I think if there was available, then I would have tried my best, and I would have tried my best to get there to the A star. So that's what I'm going to go through. That's what's coming up in this video. How I got that, how I got those high scores, and that's my best tip essentially for getting those high scores. And I'm also going to talk about uncertainties, because I was asked a question before about uncertainties, and I didn't think I went through that very well live last time, so I'm going to go through that this time. And I'm also going to give you some names of some other YouTubers that I think are excellent, and I think could actually help you out with your GCSEs, your A-levels. So stay tuned for that. There's just a big list of those coming for. All right, how did I get that great grade? How did I get those A stars? Well, and this is not about me bragging, by the way, this is about helping you guys out. It's about exam technique. It's about, I had a really good method. To attack all of those questions. And I did think about it like that. I did go through those questions in those exams with a kind of methodology, all right? By the way, all show notes are linked up below, okay? Everything I'm going to talk about is already in the description if you want to go and check that out now. There are great questions already coming through, but I'm not going to just stop just for now. I'm going to answer them later on if that's okay with you, because that will kind of interrupt my flow. So I have a video, and it's linked up in the description as well, which goes through my tips to answering different types of questions in GCSE physics papers. And I suggest that you do written questions in a slightly different way to the calculation questions. It's going to be obvious if it's a calculation question or a written question, so you need to approach them slightly differently. So here's my kind of method, 1, 2, 3, 4, step-by-step method to attacking written questions. And I promise you this is what I did for my real exams. And this is what I recommend students do now. So firstly, always read obviously the question, but underline the command words. And so that's explain, describe, everything like that. That's going to tell you the type of answer you need to give. That is the most important word. Just underline the command words. The rest of them are just as important as each other. Okay, they're all important. You don't need to be highlighting or underlining everything else. Just go for the command words. Okay, then think, what knowledge do I need to apply to this? What part of the syllabus do I need to apply to this? And I've just done a video just in the last couple of days about how to decipher questions and how to apply your knowledge to the questions. So you might want to check that one out. Then have a little plan for a written question. Is it better to use a diagram? Is it better to write in paragraphs, especially if it's a longer structured one? Is there a certain sequence that is best to explain this in? And then write it. Okay, so after you've at least, even if it's just 1 or 2 marks, just paused and thought about your answer before you go ahead and put pen to paper. And then check. And I've underlined check on this because I want you to check back with the command words. Because after all, it's the command words that told you what to do. Now, I will promise you this, every single mark on a GCSE paper is linked to a command word. So know the command words for your syllabus, A-level as well. Know the command words for your syllabus, know the types of command words they use in those exams. Okay, calculation ones are slightly different, and that's the most important for the methodology. Firstly, identify all the data. And this is what I used to do. If I've got acceleration, initial velocity, all those different things, I would write A equals, and I would write down the thing that I have. U equals, and I'd write down the thing that I have. And then all that data would be there for me to use later. After you've identified all the data, then you go to your equation sheet, or you bring it from your brain. You select the equation, and you think to yourself, do I need to rearrange? The first thing, sorry, I've skipped ahead slightly, because also check the units. If it's not in SI units straight away, convert early. Because if you convert early, then you won't have to convert later. You won't make those mistakes later on. Then, once you've got your equation ready, you've got it rearranged, then input the data and do the calculation, okay? Then you're going to check your answer. Is it sensible? Check the coherence of units again. Even go ahead and put those numbers back through the calculator again. Count off the numbers of zeros or do the standard form again if you need to, but do something to actually check that answer there. So that, honestly, that is how I got good grades in GCSE and A-level physics. I just had a kind of methodical approach to tackling those questions. All right, I hope that helps, guys. It comes down to this kind of basic structure, which we kind of teach here for all GCSE and A-level. Firstly, read it, decode it, plan your answer, then go ahead and answer, then check back. All right, so remember, it's a bit like a game, an exam, okay? Just try and pick up marks. You don't have to solve it all. you just have to try and get a good percentage of marks. Okay, nobody's trying to solve it all. In fact, a good pass will probably be like about a third of the marks in these years GCSEs, and maybe slightly more in these years A levels. So don't worry too much about getting everything right. Nobody gets everything right. Just try and pick up those marks. Okay, there are also some recent videos, just a brief interlude. There are some recent videos in the description. Okay, one is how to decipher the questions, which is my most commonly asked question. And we'll get to your questions just in a little while. There's also a video about how to memorize equations for GCSE physics. I was meant to have my book here to show you, but I've probably done that to death, and you probably know what my book looks like. You can get that on paperback now as well. And also my OCR Gateway paper playlist. I am going to finish that. There's loads of people asking about OCR Gateway playlists. That's linked up below. I am going to finish that and the second paper, and I am going to finish the AQA GCSE paper as well, which is all in playlists. Okay, I will get them finished before your exams. All right. Okay, moving on, it's about uncertainties next. But before I say that though, the best tip in my last live feed was actually not by me, it was actually by one of the viewers. So I can see that you're responding to each other's kind of questions and points there, and that's really, really useful. So do that in the live kind of feed. It was the FBI, it was a way to remember the different fingers in the Fleming's left-hand rule, and it was force, field, and current, F, B, and I. Okay, so that's a really, really super useful thing. Right, uncertainties then, I'm going to flash through, and that bong was my computer saying it's about to die. So if it dies, then I'm not going to have my notes. Okay, so anyway, uncertainties, this goes for GCSE and A-level. Firstly, we'll start off with the absolute uncertainty, and we notate that with delta x. That's the possible uncertainty in any one measurement. We normally write it like this. So if x was 4.6, that's what we measured, and we measured with a millimeter ruler, then that absolute uncertainty, one way we could do it, right? One way we could do it would be plus or minus a scale division. But that's only one way we could do it. So there's a difference between the absolute uncertainty and the percentage uncertainty. So the percentage uncertainty is that absolute uncertainty divided by the actual reading itself times by 100. Okay, so you can all calculate percentage of things. That's a simple skill. That's an important distinction to make though. Okay, now if we've got that down, okay, then there's only really two different ways to deal with uncertainties. There's a way when you've got results and a way when you don't have results. Okay, and there's different ways within that, but that's the two kind of main thing to kind of think about. If you have results, firstly, okay, well then there's loads of ways to do that. You can calculate a mean, and you can calculate a range, and you can say that half the range is the uncertainty in that measurement, because it could be the very top of the range or the very bottom of the range, right? Or you could say the longest distance from the mean, that's the range, that's the uncertainty as well, and that's a possible way of doing it. Right, there's other ways of doing that as well though, because that would imply there's a difference between each individual result if we work like that. So you can actually show your uncertainties as being the range in every single reading on, let's say, a graph. Okay? That's, again, if you have results, you can do that. You can't predict. And then we could also do an uncertainty, and especially if this is the result as kind of a gradient of a graph, we could do a most and least slope uncertainty. So you could do your graph with all the error bars on it, do the highest gradient and the lowest gradient that's possible going through all those error bars, and work out the difference between those, and that could be your uncertainty. Okay, that's if you have results though, okay? That's statistically if you have results. Now, if you're predicting, then you can use the uncertainty, the resolution of your measuring device. And there's a lot of discussion about whether or not the measuring device, the uncertainty is a whole scale division or half a scale division. And I think actually, if you justify what you do, the exam boards will accept whatever you do. Okay, if you say, no, I'm doing this because I think that's more important. So for example, with a ruler, you're actually using the scale twice. You're using it to 0 and you're using the other end. Right? But everything I've ever read, it says uncertainty is half a scale division. And that's for predictions. Okay, so you can use that to predict your results, right? Now let's say you go ahead and you make a calculation with some things you measured. So you measure mass and measure acceleration, let's say, okay, just any variables, and you calculate a force. Now, the uncertainty in the force is a difficult thing to calculate, and this is a really important skill for these upcoming A-level exams. You don't have to do this in GCSE, so don't sweat it. But you got to remember that you have to add the percentage uncertainties, not the absolute uncertainties. Why can't we add the absolute uncertainties? Because they're different dimensions. Force, mass, and acceleration are different things, so we can't add them up. Okay? You have to add things that are the same dimension. So we take the dimensions out. Yeah, we literally divide by all the dimensions, and we take the dimensions out. We just add the percentages, and that can allow you to work back and work out the absolute uncertainty for the thing that you've calculated. But just remember, when you're compounding uncertainties, that you have to add the percentages. And what you can do, you can then calculate a percentage difference, which is if there is a true value, if there's an accepted value, you can compare your calculated value to that and work out the percentage difference from it. And if that percentage difference is smaller than your uncertainty, you can say that's been an accurate experiment. You can say that's been a success. Okay, that's pretty much uncertainties in a nutshell. My other advice with uncertainties is go to your syllabus, go to your spec, and find out exactly what they say about uncertainties. Just do Control F, uncertainties, go through it. There'll be a page in the spec which tells you exactly what your specification is treating uncertainties at. That's from the Edexcel one. Okay, last thing, just before I get to your questions, okay, is some shout outs to other YouTubers, okay? This is a list for you, really. Maybe you know these already, maybe you don't. But I'm just going to go through this list of different YouTubers that I think are really excellent, and they're going to help you out with your sciences, either GCSE or A-level. So Primrose Kitten is the first one, and her channel is Science and Maths, okay, and she does GCSE Physics and Chemistry, and Biology now, and she also does GCSE Maths, and on that same channel she has some A-level Chemistry. Go to her website, that's linked up, because then you can see the things. Chris Gozard is IGCSE and International A-level Physics is the main thing, okay, great channel. Christopher Thornton, you've probably heard about them, that's a GCSE Sciences, mainly AQA, but all GCSE Science are covered in there. Cowan Physics, I think, is a really good one, especially for the A-level. Okay, he does do some GCSE stuff as well, but mainly his stuff on his channel is A-level. And Dr. Physics A is the oldest one, and he's not made a new video for quite a long time, but his videos are excellent. They are one of the earliest kind of YouTube physics explanations, so definitely go ahead and find them. GCSE Chemistry Teacher, you know what they do on that channel. That's really loads of stuff for the GCSE Chemistry. Free science lessons you've probably heard of as well, that GCSE only, but all free sciences and mainly AQA. Hegarty Maths, I bet you've seen them, okay, that's probably the best maths YouTuber out there. Mr. Smith's Physics is for you guys in Scotland, okay, Scotland's a very dear place to my heart. But if you're doing National 5s or you're doing hires, then Mr. Smith's got you covered, okay, Mr. Smith's Physics. Mr. Ray Chambers is Computer Science, okay, so if you're doing a Computer Science GCSE or A-level, then that's a good one to go there. Science Shorts, GCSE, I think they do some A-level videos as well for science. Really good, and of course A-level Physics Online. Lewis, excellent group of videos as well, and he's going to start GCSE Physics from next year. Predictably, my computer has died, so I'm trying to remember the other things that I meant to cover, so apologies if this is pretty poor. The other thing I meant to say was help me out on my way to 10K, so partly doing these live feeds, I really want to help you out with the upcoming exams, but I also want, because YouTube is sending out live feeds a bit more readily to subscribers and people who might be interested, I also want to gain in my subscriber count. So can you help me out with that, please? Can you share out these videos if you don't mind? Well, that would be really helpful, much more helpful than anything else you can do. It's a good way to say thank you. Okay, and there's one more thing, I've just given you that full list of YouTubers. There's the last bit in the description is my video explaining why YouTube is not that good for revision. Okay, I think it's actually better for this type of thing, this type of advice. But for revision, you need to couple it with something. You need to couple it with some questions. All the revision guides have good questions in them. Past paper questions, all the mock exams that you've done. Couple your YouTube stuff, use it as like a textbook to find out stuff that you need to know to tackle questions. The more you practice questions, the more that you get a kind of method of solving those questions. The easier those exams are going to seem, and the better you're going to do in them. Okay, and I promise you that is how I got good grades in my own GCSEs and A-levels, and that is what I recommend to you guys now and to my classes at school. Okay, questions from you guys right now. Okay, let's have a little look through. So we've got loads. Okay, that's really good. Okay, past papers are awesome. Westbrook, yeah, that's definitely the way to go. As I said, I will be finishing the OCR Gateway physics papers. Both papers will be done in time for those exams. There's much more OCR coming this week, AQA perhaps next week, but it's still a couple of weeks. 23rd of May is the first physics ones. Why is there no one that goes through physics solutions? All right, I do, but you know that like they take quite a while to actually edit down and make them kind of quick enough. Okay, so I will have full Edexcel papers. I do have full Edexcel papers for A level. I do have full GCSE papers. The old specs. Okay, I had them all done. I do have OCR Gateway this year coming, and I do have AQA this year coming as well. So now I've already collaborated with A Level Physics Online, and we do AS. I've done AS Edexcel papers on his channel. So it's good. We are also planning some things to work together as well in the future, because we've already worked together a little bit on Uplearn, so we know each other reasonably well. But yeah, I'm looking forward to working with him, and hopefully we could be a bomb. Especially as he's going into GCSE now, which I think is really awesome. And I don't know if you've seen him. He's coming away from teaching. He's taken a step out of the classroom to focus on his internet stuff, his YouTube stuff. Hannah, could you please go through an entire A-level physics paper working through the solutions? Have done, buddy. It'll be linked up. Most of my playlists are linked up there. If you go to my homepage, the A-level physics section, there are 3 Edexcel papers for you to go through. Okay, so I hope that helps you too, Ali. Yeah, Edexcel, that's what I've done. Yes, Edexcel, indeed. GCSE for OCR Gateway Mubin is coming. Well, I've already gone question 6, I think. I've filmed them all. I'm just kind of releasing them as I go because they take a bit of time to edit down. GCSEs are easier than A-level, and there's a video comparing the difference between GCSE and A-level physics. And it's all about working at the higher challenge levels for longer. All right, GCSEs have got harder. I was looking at some maths GCSE questions that some kids were doing, and it was like a kind of hidden simultaneous equations question in this maths thing, and that's pretty challenging. That's quite a challenging thing. All right, I'm a bit concerned about running out of time. Mainly Edexcel passed paper 3, but passed until unit 4 and 5. Yeah, I know that. I'm being ruthless with the stopwatch. I'm moving on, but it's tight. Am I alone? Are you alone with time? So what do you guys think? Are you alone? Like, do you get to the end of the paper, or do you run out of time? Do you want to just give a little shout to Lindsay? Just tell her how she, do you think the same thing? Like, do you run out of time in the papers? I think that is about being tactical sometimes and making sure that you've at least tried to pick up some marks on the last ones if you're running out of time. So it might be worth just thinking, right, this question is going to take me a bit of time. I'll leave it for a second, but I know that if I put down this equation and define the terms, or if I get this statement in there, I know I'm going to pick up some marks. So maybe just try and think about it like that. It is about being tactical. As I said, it's like a game, okay? It is definitely more like a game than it is really testing your knowledge. It's testing your ability to pick up marks, which is annoying, I know, but like, if any of you have got a better way of testing out a whole cohort of people than an exam, then we need to know, because none of us like exams, but they're a bit of a necessary evil. All right, I hope that helps. But yeah, I don't think you are alone with the time being an issue. Certainly in the kids at my school, they often do run out of time. So don't sweat it too much, bud. If you draw a graph with uncertainty squared or cubed, then the results can really vary to make it hard to draw a straight line graph. Do you just guess with the line of best fit? Yeah, I like your thinking. They're unlikely to, if they're designing data for you to plot a graph, they're unlikely to give you something that's so hard to spot the line of best fit, but they are going to give you some tricky lines of best fit. I'll just say a little bit about that. So you're talking about, so if you use like r squared, then you have to basically double the percentage error in r, because it's like saying you've done r times r, so you have to add the percentage error again. So if you use r squared, then the uncertainty does increase. Okay, so do think about that. As I say, they're unlikely to give you something that doesn't lead to a line of best fit. Okay, really quick video for momentum. I think I went through momentum in the live feed not that long ago, so maybe just skip back to that one. Also, there are loads of videos about momentum on my playlists, okay? So there's GCSE ones, there's A-level ones. I hope that's okay, hashtag. Physics is so hard. Well, the exams are so hard, but it's not like the actual physics is so hard, and that does annoy me, I must admit. I would make physics exams easier if I was the emperor of physics. Help me get to 10K, or no, help me get to be emperor of physics. That would be good. And I will make physics exams easier because I want people to be more interested and more like less put off. And you know, it's almost like some people who would really love physics and really do great at university don't get there because A-level physics is a bit too much of a challenge. But just focus on getting to, you know, a good enough grade. Don't think that E at A-level is bad, because it will get you onto a physics course somewhere, all right? That's an important thing. Okay, so get that grade, show them you can do it, and go study physics at A-level because go study physics at university because it changes when you get to university. You start working on projects, you start working on real science, you start working on things that actually matter to the world of physics right now. And what happens at university is hard work pays off more than kind of natural aptitude. And exams favour those people that are naturally a bit quicker at thinking. It's the time thing again, isn't it? And naturally a bit better at problem solving. All right. Yeah, I haven't done a hardback, but there is a paperback for the physics equation, so that is linked up. I don't think it's linked up on this one actually because there's so much to put in, but it is certainly linked up in loads of things. Yeah, the practical physics book is really, really good. Make sure you do, if there's a practical physics book that exists for your course, then buy it. That's really useful. I'm the same timing as Lindsay. Yeah, good. Okay. As long as you've done the practice and you've done the theory, you rest assured that everyone's in the same boat. And you do kind of get compared, your marks, they are worked out. If you do what's called a bell curve, which you'll know about if you've done statistics, and the grades are all worked out on that bell curve. Guys, that's been 21 minutes. I've enjoyed that. Thanks for your questions. If you've got ideas for the next one, then I'm putting all those ideas down and I'm trying to fit them all in. It's probably only going to be one live feed this week, just this one. All right, so don't expect there to be one on tomorrow or Friday, okay? But yeah, check out the playlists that I've talked about, check out the other links, okay? Spread the name if you don't mind. Tell your friends. Fleming's left-hand rule was F, B, and I. Catch you later.